Now we will be solving a problem related to inductors. We have in this particular circuit a current source which is Is equal to 3 e to the power minus 3 milliampere, and in 3 inductors, L1 equal to 20 millihenry, L2 equal to 4 millihenry, and L3 equal to 6 millihenry. Let's consider that the voltages across L1 is V1, across L2 is V2, and across L3 is V3. And the current flowing through L1 is I1 amperes, and through L2 and L3 I2 amperes. Now we got to find V1, V2, V3 and I2 at t equal to 1 second. Also we got to find the energy stored by 20 millihenry inductor, that is L1, at t equal to 1 second. Now, inductors L2 and L3 are in series. Therefore, equivalent inductance L23 is equal to L2 plus L3, which is equal to 4 plus 6 millihenry, that is 10 millihenry. Now, inductors L1 and L23 are in parallel. Therefore, L123 is equal to 10 into 20 divided by 10 plus 20 millihenry, that is equal to 20 by 3 millihenry, right? Okay. Now we can just reduce this circuit with the equivalent inductance, and that will give us a circuit which I am drawing now. The source remains as it is, and the inductance are replaced by L123, that is 20 by 3 millihenry, right? So this is the equivalent inductance. Now, and this is V1. So to find V1 is equal to L123 into di by dt, where di is equal to dis. Okay, so we can write 20 by 3 into 10 to the power minus 3 into d by dt into is is equal to 3 e to the power minus t into 10 to the power minus 3. Right. So which gives us, this 3 and 3 goes off, so it is giving us 20 into 10 to the power minus 3 into minus 1 into e to the power minus t into 10 to the power minus 3. That's what it is, minus 20 into 10 to the power minus 6 e to the power minus t. That is what we can tell, minus 20 into e to the power minus t microvolt. Now, at t equal to 1 second, V1 at t equal to 1 second, we can just put the value of t equal to 1, which would give us minus 20 into e to the power minus 1 is equal to 0.368. So, which gives us minus 7.36 microvolts. Now, we have to find V2 and V3. So, to find out V2 and V3, it is suggested to find I2. To find I2, we got to apply current divider rule. So, the current flowing through this particular branch can be calculated by taking the inductance of the other branch, that is L1, divided by the total inductance, that is L2 plus L1 plus L3, and then we multiply it by the total current Is. So if we put the values, then it comes 20 millihenry, L1 equal to 20, L2 equal to 4, and L3 equal to 6, this much of millihenry, and Is equal to 3 into e to the power minus t into 10 to the power minus 3, right? That gives us 2 by 3 into 3 e to the power minus t into 10 to the power minus 3 amperes. Now, at t equal to 1 second, we can write that I2 is equal to 2 by 3 into 3 e to the power minus 1 into 10 to the power minus 3, which would give us 2 into 0.368 into 10 to the power minus 3 amperes, which is equal to 0.736 milliampere. Now, let us find V2. So, V2 will be equal to L2 di2 by dt. L2 is 4 millihenry and d by dt of I2 is equal to, as we have got, it is 2 e to the power t, 2 e to the power minus t into 10 to the power minus 3. Now 4 into 10 to the power minus 3, and if we differentiate this thing, then it comes So if we differentiate this thing, it comes 4 into 10 to the power minus 3 into 2 into minus 1 e to the power minus t into 10 to the power minus 3. Which gives us 8 minus 8 into 10 to the power minus 6 e to the power minus t, this much of volts. Or you can write minus 8 e to the power minus t microvolt. Okay, so at V2 at t equal to 1 second, equal to minus 8 into 10 to the power minus 6 into e to the power minus 1, this much of volts, which gives us minus 8 into 0.368, this much of microvolt. Okay. Find V3 is equal to L3 di2 by dt, and you just put the values so you can find it by yourself. Find yourself. Now we want to find the energy W through this 20 millihenry resistor. That means W L1, which we can write half L1, and the current flowing this particular inductor L1 is I1. So I1 square, which is equal to half L1 is equal to 20 into 10 to the power minus 3, and I1 must be written like this, Is minus I2, since we know both Is and I2. This much of a square. So we can write half into 20 into 10 to the power minus 3 into Is, we can write 3 e to the power minus t, and I2 we can write, we have got the value of I2, which is equal to 2 e to the power minus t, 2 e to the power minus t into 10 to the power minus 3, and this is whole square. So now it comes down, let's take it to be 10 into 10 to the power minus 3 into here, if we take e to the power minus t into 10 to the power minus 6 e to the power, it will be twice t, isn't that? So because there is a square here, so twice t. Now 10 into e to the power minus twice t into 10 to the power minus 9, this much of watts. So now WL1 at t equal to 1 second can be found like this, 10 into e to the power minus 2 into 10 to the power minus 9 watts.